Welcome back, folks. Next to op-amp. This again is one that we have a nice set of formula. You can go look it up in a textbook. You can probably find it online. But we want to apply nodal analysis to it so we can kind of practice with nodal analysis on familiar circuits and then maybe extend that to any circuit. And that's my goal here. I want you to be able to analyze any circuit. So here's a circuit for you. Some of you may have run across it. Not all of you, so don't feel bad if you didn't. Some of you may have run across it in previous classes. We're going to say find I out. For this one, a little different. This is called the non-inverting op-amp. As I try to write with this pen. I think I'm getting better at it. All right. Non-inverting op-amp. So the non-inverting op-amp, again, is going to have a gain of 1 plus 12 over 4. Okay, the 12 and the 4 come from there, and the 1 is, well, we could derive that if we use nodal analysis if you wanted to. So that looks like that's going to be 3 plus 1. Stand back. I'm going to do that one in my head. It's 4 volts per volt. Okay. And then we can say V out, which is going to be the voltage over here, is going to be 10 volts times 4 volts per volt, or why did I write a 4 there? There we go, volts per volt, which is equal to 40 volts. All right, 40 volts. We could then find I out, saying that's V out over 8 ohms, so 40 divided by 8, of course, is 5 amps. So we can do that. It was quick, but it only works for this circuit. And only being able to analyze this circuit doesn't make you very useful. It just doesn't. I'm gonna go pay to buy the textbook instead of paying your salary and your benefits and all of that stuff. I'm just going to buy the textbook and I'm going to do it myself. The true value comes in being able to analyze any circuit. And we're going to do that with nodal analysis. All right. So we label our non-reference nodes. So we have one up here, right, where those two connect. Call that A. We have one here where these 3 components connect. And we have one over here where those connect. Right? Ground is all the way along the bottom here. So that is our reference node. These are our non-reference nodes. Label our passive components with current directions. So we'll go like that. Voltage supply is active. Op-amp is active. Okay, I need 3 equations. I see a voltage supply, 1 kVL. I see an op-amp, 2 kVLs. And then I'll make up the difference with a KCL. Okay, so we have a little plan for ourselves. We're going to write, let's see, I can write it over here, 2 kVLs, 1 KCL, and that gives us our 3 equations for our 3 unknowns. Okay, let's do it. Which one do you want to do first? He says months before you'll watch this video. Let's do the KVL for node A, which is this voltage supply. So VA is on the positive side, 0 is on the negative side, and that has to equal 10. So VA equals 10. I dare say we've seen that one before. Okay. Now we have, ooh, look, the negative side, or one of the terminals, is not connected to ground, so that makes this slightly more interesting to me, hopefully to you, in that it's helping you learn how to do this. Okay, so the KVL for the op-amp, I look at what's connected to the positive side, I subtract what's connected to the negative side, and I know that that has to be equal to 0. And that one's done. Okay, and that's why I like writing it that way. It's ready to go. All right, now I got to write my KCL. Okay, I can't write it for A because of this voltage supply. I can't write it for C because it's connected to the output of the op amp. So that leaves me with B. Okay, so I'm again going to write it for B. It's not always B. It just happened to be B for this circuit and the one in the previous video. Okay, so don't get complacent with that. KCL for B, we've got negative VB over 4 for this current, and we've got negative VB minus VC over 12. This one's 0, and I can really draw it either direction because it's 0, and that comes from the assumption about the ideal op amp. Right? So that's entering, but that's 0. I will start leaving that off in coming videos. Boop, boop, boop. I'll start leaving that off in the coming videos. Okay, all of that equals 0. So a little bit of algebra on that. It looks like we have negative 1/4 and negative 1/12 in front of VB. So that's going to be negative 1/3 VB and plus 1/12 VC, and that's equal to 0. Okay, look at that. We got all three of our equations lined up, ready to go. Still behind my head, though. There we go. Sorry about that. Let's make a matrix. Do you want to make a matrix? I'm sorry. I'm so sorry. Okay, 1, 0, 0. I think I need to get out of the house more. What do you think? I think we all do. Okay, so that's that first equation. Coefficient of VA is 1. There is no VB. There is no VC. Right-hand side is 10. Moving over to this one, coefficient of VA is 1. Coefficient of VB is negative 1. There is no VC. And the right-hand side is 0. Moving over to this one, coefficient of VA is 0. Coefficient of VB is negative 1/3. Coefficient of VC is 1/12. Right hand side is 0. This is going to give me my vector of unknown node voltages, just like that. All right. Calculator from here. It's a 3 by 3, 1, 0, 0, 10. 1, negative 1, 0, 0, 0, negative 1/3, 1/12, really slowing me down entering these fractions. All right, and from that, I could have done this in my head, but I like checking myself. That kind of gives me some confidence that I did all this right. Okay, VA was 10, and we have an expression. One of our equations said that, so man, it better be. You know, you could substitute it in everywhere. I don't trust myself. Why not? When I have a good tool that I can use, write the really simple equation. Because if I know I get this equation right, and then I use some tool to do all the algebra and calculations for me, I'm a lot less likely to make a mistake. So I kept this equation simple, and I just stuck it in the system of equations. It better be true. This one tells us that A and B have to be equal, right? Because if that's going to be 0, these two things have to be equal. So VB is 10, so I like that one. And then finally, just like we found with the pre-canned book formula, it's behind my head, but it is in fact positive 40. Okay, so we're doing pretty good with that. Those are our node voltages. We've got to come back and say, well, what I really wanted to find was I out. And if I want to find I out, I do the tail tip over the resistance thing, right? So because it's a current, and it's a current through a single passive element. So the polarity, according to passive sign convention, is going to look like that. VC minus 0 over 8 is going to give me I out. Okay, so I out is equal to VC minus 0 over 8. That's ohms. And I plug that 40 in there. I get 40 over 8. And that's 5 amps. That matches what we got earlier. All right. Took a lot longer, but hopefully you're getting a little more comfortable using nodal analysis on an op amp. Let's look at some more complicated circuits, and let's do that in the coming videos. Stay tuned and good luck.